Hi students, this is Mr. Yao. Today we're going to talk about 9.8, where we will learn about trig ratios on a Cartesian plane. So something that we have learned before, just the triangles and the trig ratios, but this time we're putting in a coordinate system. Let's have a look. When we first define the trig functions, the angles are between the 0 and 90, but we have just learned about radian and degree, and now we can expand our angles to way beyond 90 degrees, way beyond 360, to be however big we want and however small we want with the negative angles. So since it's in a coordinate system and they are our typical x-y coordinate, that means we can actually form a lot of right triangles, and that's where we can use the trig ratio. So if we actually construct using the grid or the x and y coordinates to form the right triangle, for example, as shown in the graph, we can have the x coordinate, we can have the y coordinate, and since we're forming angles and we're just turning things around, we're just rotating like an array, we're just going to call it an R because it's going to form a circle eventually. And if you look at this right triangle, clearly we can solve for the R. That's got to be the square root of x squared plus y squared. That's how we can find the R. And if we look at this, since we have the angle theta, that's got to be the opposite side, that's the adjacent side, and that's hypotenuse. Of course, we can actually have the trig ratio right here. Sine theta is y over r, cosine theta is x over r, tangent theta is y over x, and then the other three are just flipping all the fractions we had. So here's how we can actually use those. Number 1, 0.34. 34, that's around right here. I can form my triangle. That's got to be 3, that's got to be 4. I can solve for the other side. That is going to be 5 after Pythagorean theorem. And since this is the angle I'm representing, sine theta is going to be opposite over hypotenuse of 4 over 5, and that's 3 over 5. Tangent is 4 over 3. Then I just flip all of them. 4 over 4, 3, 3, 4. Well, that's the first one. Second one, 12, 5. So 12, 5, which is around like right here. That means this has got to be 12, and that's got to be 5. And I can solve for the hypotenuse, that's going to be 13. So sine is 5 over 13, 12 over 13, that's 5 over 12, then flip all of them. So again, you can also just use the trig ratio labeled before. You don't have to find all of these. You can just see, oh, wait, that's my x, and that's my y. My sine is actually going to be y over my r. My r is the 5, so 4 over 5. That is x over r, that's 3 over 5. That is y over x, so 4 over 3. You can also look at those based on the ratio we just defined. Number 3, -1, 7. So -1, 7 is around right here. The only difference compared to the triangles we used to present is, this time because the coordinates, this is the angle we're actually trying to present, it's not even inside the triangle, which is why we gotta use the actual coordinates. We're not just treating it as a distance, we're just using it as how it is. So that's -1, and that is 7. We can solve for this side, and this side is going to be square root of 50, so 5 square root of 2. My sine theta is going to be the opposite, so 7 over 5 over 5 square root of 2, 10 by square root of 2, so 7 square root of 2 over 10. My cosine is -1 over that. Same thing, that's got to be negative square root of 2 over 10. My tangent is 7 over -1, which is 7. Now for cosecant, secant, and cotangent, we're just flipping everything. So 5 square root of 2 over 7, 5 square root of 2 over -1, so it's just negative. And this is -1.7. So the key is when we actually put it inside the coordinate system, we are going to use the actual coordinate, use the negative numbers. Next, 2, 0. 2, 0 is actually right here. This time, let's actually practice using the ratio. My sine is y over r, cosine is x over r, and tangent is y over x. So in this case, I can see, oh wait, I don't even know my r, but my r is actually just right here. Imagine you have like a super small triangle, and you're just squeezing it, squeezing it, squeezing it. You can see this r and the x are basically the same. That means in this case, my r is 2. So y over r is basically 0 over 2, that's 0. Cosine is x over r, so 2 over 2, that's got to be a 1. And tangent is y over x, so 0 over 2, which is 0. Cosecant, I just need to flip them, so it's basically 2 over 0. Well, can we actually divide a fraction by a 0? Probably not, so this actually is not applicable. Secant, flip 2 over 2, that's just 1. Cotangent, 2 over 0, that's actually NA as well. That's example 4. Example 5, negative 6, negative 3. So negative 6, negative 3 is around right here. Well, not there. Actually below. Negative 6, negative 3 is around there. So the angle representing is right here. Even though it's not inside the triangle, we can still use the ratio to represent, because that's kind of how reference angles work. So sine theta is going to be, well, we need to find the hypotenuse first. So our r, that's going to be 3 squared plus 6 squared, which is 3 square root of 5. So sine theta, negative 3 over 3 square root of 5 times 5 square root of 5. The 3 is going to cancel, so the final answer is going to be negative square root of 5 over 5. This one, negative 6 over 3 square root of 5, same idea. That's going to be negative 2 square root of 5 over 5. Tangent, y over x, so negative 3 over negative 6, which is flip for the other 3. This is going to be negative square root of 5, negative square root of 5 over 2. This is 2. Again, you can also think it as y over r, x over r, and y over x. That's the words. Number 6, 0, 5. So 0, 5 is actually right here. That's our x, that's our y. So let's think about it. If that's where the angle is, I basically have a super big triangle, like that. But I still need this side to actually be a 90 degree. Well, then that means my r is actually going to be 5. Y over x, r, x over r, y over x. Y over r, 5 over 5, that is 1. 0 over 5, that is 0. And my tangent, 5 over 0, well, it can't divide by 0, so it's NA. Cosecant, just flip it, still 5 over 5, that's 1. Secant, 5 over 0, that's NA. Cotangent is 0 over 5, that is a 0. That's example 6. So if you actually have a look at all of these, you will notice something. Since it's a coordinate system, we have quadrants. Let's actually pay attention to the quadrants. This is in the first quadrant. We can see sine, cosine, tangent, they're all positive. This is still in the first quadrant, they're all positive. And then you see example 3 and 4. This is in the second quadrant. You can see tangent, cosine is negative, tangent is negative, sine is the only positive. Example 4, this is not in any quadrant, so we're not considering it. Number 5, this is the third quadrant. You can see sine is negative, cosine is negative, tangent is the only positive one. So now we can have a look at how the positive and negative is actually defined. So that's my first, second quadrant, third quadrant, and fourth quadrant. In the first quadrant, all of them are positive. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. And fourth quadrant, only cosine is positive. So here's something that may help you to remember how these values should be. We have something called A, S, T, which is all students take calculus. You can see all in the first quadrant is just going in this order. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. And fourth quadrant, only cosine is positive. Now, after finding the ratio, this time we are going to find the angles. Let's get started. First 3, 4. That is about right here. 3, 4. The angle we're trying to find is right here, theta, because it's asking for standard angle. So we gotta start from the positive excess because that's the initial side. So if you look at the triangle we're gonna have, this is 3, that's 4. Clearly, we can use the tangent. And theta is 4 over 3. So in order to find theta, I just need to take the inverse of inverse tangent of 4 over 3. That's going to give me 53.13 degrees. And since that is already the angle, that's the standard angle, I don't need to change anything. 53.13 degrees. Number 8, -1, 7. So this is the angle I actually need. But my triangle is right here. The problem is, whenever we have these trig ratio, the same ratio can actually be presented by many, many angles. So we can't exactly just use the negative. We can't just use the numbers and plug it in to find the actual angle. That won't always be the one we want. Which is why when we try to find the angle, we are just going to find the reference angle first, which means we just ignore the signs. So my tangent, whatever angle, is going to be 7 over 1, so 7. And, well, since actually it's not theta, I'm just going to use a question mark. So that's the question mark. The question mark is going to be inverse tangent of that, which is going to be 81.87 degrees. So the 81.87 degree is actually right here. This is the 81.87. Now you can see if I want to find the angle I actually need, I just need to use 180 minus whatever this angle is. And that is going to give me 98.13 degrees, which is the actual angle I need, the standard one. Number 9, -6, -3. So -6, -3 is right there. The angle I need is here. That's my theta. But if I want to look at the triangle, that's not the triangle. The triangle is right here. This is a -3, that's -6. So I'm going to need to find this angle first. So that's my question mark, because that's basically my reference angle right there, right? So tangent question mark is -3 over -6. So the question mark is going to be inverse tangent of 1/2, which is going to be 26.57 degrees. Now, if you actually look at the standard angle, well, I just found this little part. In order to find the standard one, I just need to add all these extra, which is 180. So 180 degrees, 26.57 degrees. That's going to give me 206.57 degrees. That's number 9. Number 10, 2, 0, 2, 0, right there. Well, that means the initial side and the terminal side are actually the same. In this case, I don't even need to solve. That angle itself is 0 degrees. Oh, and I just realized the question asking to round to the thousandths place. So that's got to be a 565. And the previous one, this is going to be 90. Well, 70. That's still going to be 130. And the previous one, that's a 0. So it's a 0. Okay, next, number 11. -7, 0. It's right here. which means my angle is this one, so it's 180 degrees. Number 12, 5, -3. So 5, -3. The angle I'm looking for is right here. However, if I just look at my triangle, that's the triangle, and this is the angle I can't find because that is my 5, that's my -3. So basically, I still find my reference angle first. So tangent, that's the question mark. Tangent question mark is 3 over 5. Question mark is inverse tangent of 3 over 5, which is going to be 30.964 degrees. And if you look at it, the relationship between the red angle and the green angle, well, they actually make up 360. So I just need to use 360 degrees minus 30.964. And that is going to eventually give me 329.036 degrees. And that's the angle that I actually need. That is everything for 9.8. Thank you.